Great. Thank you, everybody, for joining us for another Cloud Security Masterclass. Today, we're going to dig into the blast radius of a cloud misconfiguration breach, what that means, what it looks like, how to spot it, and what you can do to minimize it to ensure that any incursion into your environment doesn't lead to a really bad day. Before we get to Josh and the topic at hand today, wanted to kind of hit on a couple of resources that are available to you. Obviously, this is not the only masterclass session we've ever done. We've done a ton of them. They're all available to you on demand at fugue.co/masterclass. These range from kind of technical deep dives into specific subjects such as identity and access management, as well as some kind of higher level strategic kind of critical thinking type of topics and approaches to the subject. So do check those out. We also have the State of Cloud Security 2021 report available to you. And relatively new is the Engineer's Primer on Cloud and Infrastructure as Code Security. This is a chock full of insights and actionable steps you can take to not only kind of understand the nature of cloud security issues and the risks and challenges, but ways that you can improve your cloud security posture more efficiently so you can move faster and more securely. One thing that's kind of hot off the press that I don't have on the screen, Sivia is going to pop it into the chat. We have a Fugue Lunch and Learn coming up on December 7th at noon Eastern. Our friends and Fugue customer, Red Ventures, they're the company behind a lot of brands, you know, Bankrate, CNET, Healthline, and many, many more. They're going to join us to walk through a use case with Fugue of really how they were able to onboard a massive cloud environment that spans multiple cloud providers, lots of different environments there for a lot of their different properties, how they were able to kind of bring all that into view from a security and compliance perspective very, very quickly, as well as writing some custom security policies using Fugue and Open Policy Agent to give them a kind of a better view of where they stand with regard to some of their internal policies. So do join us on December 7th for that. It's going to be really interesting, a lot of fun. Awesome customer, Alfonso Cabrera over there is great. So I think you'll really enjoy it. With that out of the way, why don't we get going with the program? Hey, Josh, are you there?
Hey, Drew, I am here. Good to see you and good to see everyone who's here to attend the class. Can you hear me okay?
Yep, you sound great.
Okay, perfect. So yeah, we're going to be talking about, well, let me get my slides up too. Here we go. And we'll go to our agenda. So we're going to start today with some basic concepts around security and the concept of blast radius. We're going to then, and we'll spend some time on this because I'm not sure it's a very well understood term. And I think it's absolutely maybe the most essential thing to understand in a practical security regimen, because it's what you're trying to prevent. It's talking about damage that can be done. And there are lots of kinds of damage that can be done. So we're going to spend some time on that. Today's session is mostly going to be at the whiteboard and a little bit of web browser. But it's unfortunately or fortunately for you, it's mostly me talking and whiteboarding this particular session because the topic is so fundamentally architectural. And that's going to get us into a little conversation about how you actually prevent ugly, blast radius kind of attacks, how you limit the blast radii across your computing infrastructure. And I'm going to talk to the different kinds of damage that can happen. And we're going to do a deep dive on a recent breach that had a really ugly blast radius, and that was the Twitch breach. So, and we're of course also going to talk about steps you can take to minimize blast radius. This has Q&A at the end. It's much better if you ask questions while we're going, and ask challenging questions. You know, it's more fun in these classes if you know, as the humble instructor, if the participants in the class bring up things I haven't thought about, or things that maybe I'm not intending to cover. So feel free. Let's make this nice and interactive. Drew, should we just get going? What do you think?
Yeah, let's dive right in.
All right. So what kinds of things are we trying to prevent with IAC and cloud security? Oh, I've got my, let's see if I can fix my slide real quick. I missed that. There we go. What kinds of things are we trying to prevent? Well, this is from a survey, the State of Cloud Security survey that Drew was talking about. We do it every year. This year we did it in partnership with our close partners at Sonatype on, you know, what are the 300 respondents that respond to the survey. These are all organizations operating at scale on the cloud. What are their concerns? How are they thinking about this? So common and dangerous misconfiguration, cloud misconfiguration incidents. This is what the survey respondents said they were seeing. And you'll see here, and this is going to be reflected as we talk about blast radius. IAM is number one, and IAM is a form of network, and it can be traversed like a network. And therefore, if you think about blast radius, networks connect stuff, right? So highly relevant. Encryption in transit and at rest, in this case, is also quite relevant in terms of data blast radius issues, like how much data or the type of data, right? Because some data is very large, but it doesn't really matter. It's not too damaging. And some data is quite small, but extremely damaging. So we'll talk about how to.
And we've been running this survey for each year for a number of years, and IAM has really just kind of been on a tear. Every year it gets higher and higher on the list, and this was the first year it became number one.
That's a good point. I was thrilled to see it. I mean, I think a lot of times when folks read press about cloud breaches, what they're getting is a journalist's best understanding, which is often a what's the right way to put this? Oversimplification. And so people, you know, the notion that public S3 buckets are like a major attack vector. We've been hearing this for years, and it happens sometimes, but far more often, IAM is an important part of the attack surface. It is, and part of the vector used. So yeah, it's been great to see that coming up. Always makes us happy when people are getting wise to the ways of hackers. Okay, I'm going to switch to whiteboard here. All right, we've got a whiteboard. So I want to talk about what blast radius means, and I'm going to start with an analogy. So when you're engineering systems in general, we're talking about engineering computer systems, you know, software systems primarily. But when you're engineering systems in general, the failure modes, which is it's closely related to blast radius. What you don't want are catastrophic failure modes. What you don't want are huge blast radii. So if you think about what a naval architect does, a naval architect is the name that we use, is the job title for people who actually design ships. Okay. Let's say you've got you know, a big ocean-going freighter. It's my terrible drawing today. A big ocean-going freighter, and you know, it is breached by something that pokes a hole in it. I don't want arrows on these things, whiteboard. I keep telling you that. If this hull is just one large space, that ship will sink. Okay. So in modern vessels, and by modern I mean going back, well over 100 years, the approach taken, let's see if I can draw a little bit better ship here. The approach taken is to segment the interior space of the vessel. Okay, and the reason for this, if you think about, for example, the US coal incident, where some jihadi attackers rammed a small boat into the side of the vessel packed with explosives, and it blew a really big hole in the side of the coal. But only the section or sections, it's probably more than one, that were right at the point of impact filled with water, and therefore the ship didn't sink, and it was repaired, and it's in service now. Famously, the Titanic did have it was one of the first commercial vessels to have this kind of segmentation, but it wasn't implemented as well as we do now. And by scraping along the side of an iceberg, a lot of it filled, and we know what happened. So when you're talking about blast radius, what you're really talking about is trying to limit the impact of successful penetration or hacks. Very often, security folks, engineers think primarily about the penetration, like, can somebody get in? Well, I will argue that you cannot prevent everyone from getting in. You cannot do it. You can use Fugue tools like ours at Fugue that will really, really help limit that and probably prevent the vast majority of it. But eventually, let's say, just to take it to its extreme, if a state actor, a sophisticated state actor, wants to get into your stuff, that might be North Korea. They're pretty good at this stuff. China, Russia, us, right? The United States, Israel's great at it too. They are going to. And so what I believe but even if you're not taking it to that extreme, you probably have imperfections somewhere that a hacker knows how to exploit. And of course, you're trying to prevent those. But I think at least, and probably more important, is the notion of limiting blast radius, of limiting damage. So let's talk about a couple of examples of how to measure the impact of blast radius. I had mentioned earlier, if you think about a computing system where let's say it's I don't know, Amazon.com. Let's pretend that Amazon got hacked by somebody. I don't know that this has ever happened. And every single image of every product that's ever been sold on Amazon gets breached. That's probably a massive quantity of data, but I would argue practically a very small blast radius. I mean, who cares? This is stuff they're publishing, right? Similarly, if you have large collections of public data that are accessible, from web servers stored in databases, in your hosting in your apps, that stuff tends to be low impact unless it's designed really poorly. And this comes back to, who solved, in the case of the ship, the coal, who solved the problem fundamentally of that ship being able to survive that attack? It was the naval architect. The same is true in computing. To address blast radius issues, you have to have architectural solutions. You have to know how to build stuff that does not allow a large blast radius. So I want to use one other kind of anecdote. I was to talk about blast radius and how hard this is, how multidimensional it is, and how much it requires, assessing it requires a deep understanding of your data and the uses of your data. So a number of years ago, all of my PII was stolen, along with everyone else who in recent years has held a security clearance in the United States government. We think it was the Chinese, but all that stuff was taken. So if you've ever filled out an SF-86, they know everything about me, like everything. Okay, so that's gone. So it was interesting about this breach. I was at a conference, and one of the other speakers there was a very senior scientist and engineer, both actually, from NIST, the National Institute of Standards and Technology. So these are serious folks. These are people who create a lot of the standards that are used not just in things like manufacturing, but in things like computer security. And he is one of the central authors of those NIST standards, the 800-53 standards. And he pointed out, and I don't know, he was speaking pretty definitively about this. I don't know if this is actually what happened or his speculation, but he pointed out, he said, okay, the entire security clearance database was hacked, right? And all those were taken. And then a few weeks later, maybe it was a month or two later, a website which was set up, a commercial website for people looking to be to have infidelity. It's called Ashley Madison, a website for people looking to, cheat on their partners, frankly, was breached. He connected those. He said he thought that those were the same actor. And the purpose was, in his opinion, to find people who held security clearances, who held sensitive jobs, and to be able to bribe them with information about their infidelities, which is a classic way to get people to spy for you. And we know that Chinese have a very active spying program. So what's the blast radius of the security clearance database? I mean, it's small data, right? It's very small data. Relatively speaking, it's maybe a terabyte or something, probably not even that. Maybe it's 10, it's still small. The blast radius is massive, and we're not gonna know, assuming this fellow from NIST was right, we're not gonna know its impact probably for a decade or more. It usually takes, as a kind of amateur student of both military history and intelligence history, and having done a lot of national security work, it usually takes a decade or more to really understand where spies are embedded in your organization, and usually you only find that out by getting a spy in the competing organization to tell you who they've flipped. So that's a nasty blast radius. So as you're thinking about your systems, as you're thinking about your data and what it means and to whom, you need to be very thoughtful about data and resources which are extremely high value and smaller versus the notion of blast radius that's quite broad. All right, and this class is mostly whiteboard and web browser, because every one of your systems are different, and you have to really understand what the impact to your organization and maybe to society in many of these cases could be, right? So this is an architectural concern. Now, Fugue, we will help guide you to architectures that prevent really ugly blast radius effects from penetrations, but ultimately this is on you, because every system is different. Yeah, so why don't we take a little bit of a deep dive into a real world recent large blast radius breach. All right. Drew, are we getting any questions? Folks, if you have any questions, just throw them to us, okay?
Yep, none so far.
All right, and we'll keep rolling. So here I'm on the Mitnick security website, and I've got it in reader mode just to keep all the marketing stuff from popping up. And Drew, are you still hearing me? My Zoom's being a little funny.
Yep, loud and clear.
Okay, great. So this is an overview of this breach that happened earlier this year. So in fact, just about a month ago. So what happened on Wednesday, October 6th, Twitch announced on its Twitter that it was the victim of an attack. We can confirm that a breach has taken place. Our teams are working with urgency, et cetera, et cetera. And then more than 100 gigabytes of leaked data was posted to 4chan. I think it was 128 gigs, actually. So this gets pretty interesting. So amongst the posted data, and therefore the hacked data, right, included 3 years of payment information showing how much Twitch compensated its elite gamers. Yeah, so this is all just about that one aspect of the breach. Let's see if this one, let's switch to another article on this where they talk about, here we go. So here is, and this is hackread.com, which is sometimes good. So this article is quite good. So here you've got a list of things that are included in that leak. So you've got Twitch source code for mobile and for desktop, video game, and you know, pretty much all their clients, it looks like. Okay, so let's go back to the whiteboard and let's start enumerating these. So we've got user data, right? I don't know why Microsoft keep updating this whiteboard app and it's not getting better. Okay, it's going the other way. So we've got user data. You know, in this case, that's the payout for the last 3 years of the creators, right? We also have Twitch source code. I'll just say Twitch source. All right, what else do we have here? Internal security tools information. It is not clear in this if that is source code or other kinds of documents, but we do have down here crucial details about a yet unreleased Steam competitor from Amazon Game Studios. Purportedly, I have not downloaded this data, by the way, but purportedly called Vapor. So we have definitely, we've got source code there. We've got Amazon proprietary business information.
You need to draw that box around your head there, Josh.
Oh man, thank you. Yep.
It just cut off business.
Okay, let's see. Okay, that's too far. Yeah, I can't see my my video window when I'm drawing here, so I gotta kind of, oh, that's good enough. All right. So we've got proprietary, let's make sure I'm on the right place. Amazon business info, right? And we've got Twitch security tools. Okay, let's see where else this goes. All right. Code of proprietary SDKs, that's more source code. And this one's interesting. I think that's the scariest one of all these things. It's really bad. Oh, by the way, Twitch is owned by Amazon, right? This is a subsidiary of Amazon that was hacked. And this is probably why they had access to internal AWS source code. So it's not just Twitch source code, right? It's AWS source code.
So this is like source code for various AWS services?
It appears so. So that's really bad because hackers, 90% of hacking is discovery. And if you've got source code, there's all kinds of games you can play to understand vulnerabilities in that source code. All right, well, this ship is not very well compartmented, right? We can say that by looking at this. And apparently, oh, right, let's talk about the, yeah, let's look at this. Back to the browser. We have learned that some data was exposed to the internet due to an error in a Twitch server configuration change that was subsequently accessed by a malicious third party. Okay, back to the notion that you can't prevent all penetrations. Nobody can. You can't do it. So in this case, they had some server sitting somewhere. I'm going to use the old, like the old Visio, you know, box server here. Although we pretty much know this is, you know, AWS stuff. So it'd be a cloud server. But this server got breached by a bad guy. All right, so we'll have a little dude with horns over here. And they got into this server. So now this server's red. All right, this server is compromised. This is the thing that you can't fully prevent. And by the way, getting into this server probably had almost no business impact. We don't know the details. They have not published much in the way of details, but probably had almost no business impact to Twitch or Amazon, right? An individual server, especially in a cloud architecture, is kind of by its nature not a very high value target. Okay, because I mean, unless your application is really designed poorly, you're going to be very conscious of where you store sensitive data, of where and you're not typically going to put it on the disks of a server. You're going to have, you know, some complexity in the some microservice or tiering in the architecture, some segmentation in the architecture, that server alone shouldn't be that valuable. But in this case, it was tremendously valuable, right? Because from whatever was on this server or from this server, the hacker got first, well, I don't know the sequence, but we'll first address user data. This is understandable, okay? This is, I'm gonna give myself a little more room here. This is quite understandable. Oh, not what I wanted. Let's move this guy. No. All right. Thanks, Microsoft. This is understandable because it is likely that a public-facing server, which is almost certainly what this was, I'm assuming it was behind defensive layers, right? Not just directly exposed to the internet, but it is very understandable that a public-facing server running their app would need to get to their, you know, transactional database either directly or indirectly in order to pull data to fulfill user requests on the website, right? We know that you know, the thing that made the big news was you know, how much they're paying their top streamers, and, you know, shocking, these huge internet personalities make millions of dollars. I think we all knew that, I hope. But the breach of that is therefore understandable. That server had legitimate permissions to get to that data. You don't want that to happen, right? You don't want that to happen, of course. But I understand, you know, as a security practitioner and cloud security person for a decade now, I understand this can happen. What I don't understand, what strikes me as frankly kind of inexcusable in this breach, are these other things, right? Why in the world would some server that's facing the internet, directly or indirectly, be able to get to source code, to be able to get to security tools, to be able to get to not even Twitch source code, but Amazon source code? What do these things have in common? Nothing. There should be no ability to go from a breached server that is clearly fulfilling some kind of public role because it had internet access to all of these kinds of data. So I'm going to make a hypothesis as to how this happened. We don't know for a fact, but I'm going to give you my hypothesis, and it comes back to that slide over here, identity and access management. So in the world of cloud computing, the notion of networking has really changed. I'm going to give myself some more room here. Can I make this go away, or is this just, there we go. So I'm going to talk about the old days and I'm going to talk about the new days here, because a lot of folks still think in data center terms when it comes to networking and security of defense in depth and things like this. So I'm going to talk about the old days, and then I'm going to tell you why that doesn't matter anymore. All right, so in the old days, we had what we typically called N-tier applications, which, by the way, is another way in you know, you can argue it's separation of concerns. It's a sort of early form of service architecture. So in N-tier, you would have, you know, web servers and you know, web 1, and you'd have a big pile of these guys, and they would be sitting behind the DMZ, which is, you know, the demilitarized zone. There's a lot of military terminology used in computing security, and I think usually it's actually pretty good to do that. So here's your web tier. In your DMZ, you're going to have stuff like your, you know, firewalls and load balancers very often, etc. And then you're going to have, so you've got the DMZ, you've got the web tier, web tier is my touch on. Is that what I'm doing wrong? No. Okay. You're going to have your web tier, you're going to have your app tier. And your app tier was typically where you ran application servers, right? And very often these tiers were separated by load balancers, A1 and A2 and etc., right? You're going to have a lot of these guys. And there's going to be in this traversal of network, because these things are typically defined in the old school by network, often by CIDR blocks and you know, subnets that allow access or deny access to the firewall. And then at the back, you're going to have your data tier, which, you know, in the old days was generally almost always some kind of, I'm drawing put a database back here, you know, some kind of relational database, Oracle or MySQL or whatever. So then what the rules were, the way you thought about securing this and limiting blast radius, hopefully, is by having very strict rules about what can initiate conversations and traverse these TCP IP segments, okay? So you're going to have rules and firewalls and other kinds of devices that sit between these things and watch what's going on and that filter and deny things. So for example, if this web server wanted to talk to the database server, that wouldn't work. You had to go through the app server. Similarly, very often you would disallow initiation of outbound connections from the database server and only allow queries from the public facing stuff, et cetera, et cetera. So this is part of what we call defense in depth. It is an architecture that I think everyone's familiar with. It's been around for a long time now. I got to keep track of time. Okay, cool. So why is this not super helpful in cloud? So in cloud, the way you create these relationships is different. And by the way, this is the reason I'm getting so architectural is that fixing limiting blast radius requires you to think architecturally and implement architecturally. So I think of, and Fugue think of, our product thinks of, broad architectural mistakes as themselves misconfigurations. I would argue that anything that allows penetration or allows blast radius expansion in your cloud environment is a form of misconfiguration. It is a mistake, right? The question is, how do you think about fixing that? In the case of the blast radius considerations, again, in my opinion, the most important thing, you have to fix this architecturally. And that means you need to think as a software architect. You need to employ the software architects and folks designing the system. Maybe you don't have people titled that. Somebody's doing the work of designing the system. And they need to understand what is dangerous and not from this blast radius perspective. Otherwise, you can't just buy a product that fixes this. Fugue will definitely tell you where you have issues that are scary, but we can't just fix it because this again, it's like the ship with right. These in the old days, these tiers were the maybe the chambers in the ship hull. Okay, so what is it like now? What it's like now in the cloud is you have cloud resources. Maybe it's an EC2 instance, and these are, maybe it's a Lambda function, maybe it's a Docker container. Let's see if I can do a whale today. There's a little whale. All right, maybe it's a Docker container. It's some combination of these things, right? And they serve different functions in a service or microservice architecture. And eventually they get back to data stores. You know, maybe it's a database and S3. All right, so the way these things talk to each other, typically, if you're doing cloud right, the way these things talk to each other is, and how you limit what they can talk to, is actually through their identities, primarily their identities. There are other mechanisms as well, like security group association, but you can make the argument, I think correctly, that security group membership is a form of identity as well. And this becomes the network. Okay, this becomes the network. The TCP/IP network, you know, it still plays a role, but not much. Okay, so for example, this EC2 instance, let's say this is our breached server. It probably was an EC2 instance. And let's say it can talk to this Lambda over here legitimately, and it can talk to this database legitimately. Well, why in the world would it be able to talk to GitHub? And how did that happen? Well, I'm just assuming that it was GitHub that had the source code. I have a theory. I don't know. We don't have the details, so I don't know this to be the fact, but I have a theory. And I think it's a pretty good one because I've analyzed lots and lots and lots of these breaches. And this is all I've really done for a decade is cloud security. That the AWS account that this EC2 instance that was breached was residing in probably had, if you think about IAM as a collection of policies, and those policies grant access to different things. All right, they come with credentials, with keys to grant access to different things. I strongly suspect that somewhere in, whether it was in IAM or some other identity management system, but given it's an Amazon company, probably IAM, there were credentials in there that could be used completely separately from this EC2 instance to access things like source code repos. You know, where was our list? To access things like, you know, proprietary Amazon business data. Maybe that was in their Git repo. I don't know. So the story here is then that having even those kinds of keys laying around in an account that could potentially be taken over by somebody breaching that account, right? What's the blast radius of that set of credentials that allowed access to source code repos? It's big, right? That's probably like a kilobyte of data, but it's a huge blast radius. So what I've seen often, and this gets to, by the way, I'm not trying to pick on Twitch here. It is like one, if a security researcher or expert, to the degree I am, who doesn't use real world examples, they're not covering the details, and that's where the devils live. You have to use real world examples, and so inevitably you're kind of picking on somebody who got hacked. All right.
Well, I mean, we've seen these traits with a lot of these cloud breaches over the past couple of years, whether it's Capital One or Uber or Imperva. They all have this kind of, initial misconfiguration exploit that was then, there's a much wider blast radius. I mean, obviously, all of this source code and payout data didn't reside on that misconfigured server. I always fear that the headlines are often misleading. It's like misconfigured server led to this data breach, and it's easy to assume all that data was on that one server. But the breach obviously involved a lot more than that one server. That was just the starting point.
Yeah, well put. When you look at the Uber breaches, that was an interesting one. That was kind of the reverse blast radius effect of this, where in this they're getting into a production, we assume it's a production server, some server in the infrastructure environment, and getting to the source code repo. In the Uber breaches, the hacker got to the source code repo, which gave them credentials to the production environment to go steal all the data. So there's a theme here, right? There is a theme here, which is, let's go back to our ship. How do you actually make these bulkheads when you're designing computing systems? And there is no one silver bullet answer. What you need to be thinking about is how hackers are going to view you. Okay. A lot of times in security, we spend a lot of time, frankly, I see in the industry anyway, a lot of time on theater. The only thing that matters in security is what hackers do in reality. That's what we're here for. All this other stuff is proxy, right? As we talk about things and measure different standards and approaches and so on. What we are doing is preventing bad things from happening to compute resources. That's our job. And to understand that job, you have to understand the attacks, and you have to understand them in depth. So as you think about this notion of segmentation, I'm going to describe a couple or a few varieties. I dug in pretty deep on the Twitch thing and burned some time. So Drew, thanks for jumping in there and getting me on track. Let's talk about data segment. Let's talk about pure data blast radius, like not identity blast radius. So let's say let's go back to all my PII data that was stolen by the Chinese from the security clearance database. I'm kind of resentful, to be honest. Like that didn't have to happen that way. So there are ways that you can design databases, particularly databases that are interfacing to what you have to assume are penetrated, exploited servers that are facing the internet. One thing in your architecture, always assume that everything that is internet facing has been breached. If you're not doing that, you're not considering really what the architectural problems are. Just assume anything that has touched internet air has bad guys in it. All right, so the data that you're exposing to those services, right? When you design that database, there are different techniques you can use for encryption and for segmentation of that data that would make it much harder for somebody to just grab the entire database. So for example, in AWS, there are often options like in S3 and in other data stores to use the pure AWS generated keys. Those allow for decryption of data as just a service call with the correct permissions to S3, for example. Don't do that. Use instead KMS keys that require a separate call out to the KMS service and therefore more credentials. So think of it as almost like multi-factor authentication. All right. So when you're talking about purely data, you want to think about what's the high value stuff and how do I make this really hard? How do I make it so that the hacker has to get access to 2 or 3 sets of credentials? And that becomes your interior segmentation. Your bulkheads are the difficulty of jumping from this one. I'm going to switch whiteboard programs to this one. Should require that hacker to have breached multiple things, to have multiple sets of credentials, which really raises the bar. Okay. We've talked at length about the IAM one. I have a very straightforward piece of advice on that, which is in your cloud accounts that are actually running infrastructure, like this guy. Well, yeah, like this guy probably was. Don't have the policies you use in, say, developer accounts accessible at all from a production account. So a lot of folks will do this where IAM roles are kind of federated across an organization, and you can access kind of the master library of policies. Don't do that. I don't think. What I'm saying is highly inconvenient in that you need to, probably duplicate IAM roles. But I'm arguing here that the existence of a large library of IAM policies, some of which are oriented toward development, and therefore have access to source code repos. I mean, Twitch is probably not using GitHub. They're probably using the AWS, source code repository. So it's just more keys to an AWS service in this case, most likely. So don't have those policies laying around. A lot of people think that, I hear all the time, people will say, well, I'm doing least privilege by analyzing the actual use of IAM policies on a transactional basis and limiting to the ones that it really just uses, and then I add that policy. That's not least privilege, okay? That's just observed behavior. Least privilege means that not only the policy that you're actively running, but other accessible policies are not going to be ones that will come around and bite you if they get traversed to, because the IAM policies and roles and so on are part of the attack surface. Okay, we've got a question. How many companies? Oh, sorry, Drew, why don't you go ahead?
I was going to jump in. We actually have 2 questions, and the newer one seems more directly related to what you're talking about. We'll get to both. The one that came up was, I don't get the idea of how one can segment IAM to avoid blast radius. It's probably a big subject, but
Can you read that again? I
yeah. It doesn't understand how one can segment identity and access management to avoid a blast radius.
Oh, I see. So yeah, I mean, it's challenging for sure. What you really want to be aware of, and Fugue will help you with this, but I suppose there's probably other tools that will too. What you really want to avoid is the ability for anything in your running infrastructure to be able to traverse that IAM policy surface. So for example, on EC2, I forget the action. EC2 alone has like 500 actions now. Yeah, it's high 400s. I think it's called Assume IAM Role Policy Association. Like that shouldn't be anywhere in your infrastructure, because that is a shopping cart to those things. But when you're thinking about limiting blast radius, well, let's think through momentarily. It is a vast subject, Drew, and it's a great question, and it's a hard problem to solve. And by the way, anyone who's here in this class, we would be happy, and I personally would be happy to talk through your specific concerns with you as well. So just hit us up at the
And
end.
we have a 2, maybe 3. I think it's at least a 2-part masterclass series that really
On securing
focuses
IAM.
specifically on IAM. But
yeah, thanks, Drew. we've got classes on this. I can't answer it in like a minute, but if you just consider what it took for this server to be able to get to all these things. I mean, no security is perfect, right? Defenses are defense lags offense, right? That's just the nature of that's the nature of biology, right? And warfare and computing. It just defense always trails offense to some degree. So you learn stuff all the time, and you adjust. But clearly, this lack of segmentation, this kind of diversity of compromised assets suggests that there were some really fundamental architectural flaws in what was going on there, and those you can kind of find, but there's no silver bullet to understand how to have a truly secure IAM environment. Requires understanding your business application, what data it has, how it's architected and configured. I mean, there are ways that developers build systems that cannot be properly secured. That can happen, right? And it's not just because of a bad port on a firewall. That's not the limit of misconfiguration. The nastiest misconfigurations are architectural choice misconfigurations. For example, in the Capital One breach, the ability for a server or compute instance or container or Lambda or whatever to do S3 list is a really bad architectural decision that can lead to massive blast radius. And that's exactly what happened in the Capital One breach. The S3 list command was used to find 700 S3 buckets full of customer data. Well, if list hadn't been turned on, then they wouldn't have guessed the 700 bucket names, and they sure wouldn't have guessed the content names of all the files in those buckets. So there's no silver bullet, but we do have a class on that. Okay.
yeah, so Darren asks, how many companies care about egress security group rules as much as they care about ingress?
100% of the set that understand how to secure networks. I don't know a percentage. I can't really comment on that. I will say that usually when I talk about egress rules with our customers, and our customers are a lot of really large SaaS companies, banks, and places like that. Drew mentioned, Red Ventures and SAP, NS2. We got a bunch of them. But anyway, when I talk to them about egress rules, they seem pretty savvy to it. So often it comes up in the context. And by the way, this is something to go look for right now. If you create a VPC in AWS and you let it create its default security group, which is a very common thing to do, which will kind of happen if you don't choose to not do it, you're going to get a universal egress security group policy on that VPC. So remove that. Fugue you can run Fugue for free, and we will show you everywhere you have this issue, even if you're not using the VPC. Delete the default VPC if you're not using it. So I want to get one other idea across here, and this is how to address some of this, because what I'm showing you here is the tip of an iceberg, right? This is a vast subject, and it is really advanced, and it has lots of dimensions to it, and lots of ways to answer it. Here's what I would recommend as a first step if you really want to understand this. Pick a day. Just pick a day on the calendar and tell the people who built the system that their job today is to figure out the nastiest thing they can do in terms of blast radius on that system. So this is going to do a couple things. One, obviously you're not going to do this to your production system, right? But one, it's going to get the people who are building thinking like hackers. And if you're not thinking like hackers, you're not thinking about real world security. You're thinking about security theater. So it'll get them doing that, one. Two, they'll have some fun. It is way more fun to break into stuff than to build it a lot of the time. They don't even need to actually break into it. They just need to describe what they would do, right? And three, you're getting the people who designed the system to really consider where its potential flaws are. So, I've been a programmer, software architect for like 30 years now, something like that. So yeah, 30 years now. And in Fugue, we do a lot of Lambda in Fugue. I missed a security issue that the engineers brought to me and said, hey, on an individual Lambda, if you get multiple multiple executions on the same instance, which can happen, the cache data in the local storage can traverse multiple transactions, and therefore in a multi-tenant environment like ours, one tenant might be able to see another tenant's cache data. So we architected that out of our system. But you're going to learn more by engaging the people who built the thing than by kind of trying to assert. You can also use, and I of course would love it if you did, use Fugue to help you navigate a lot of this. Okay, we're top of the hour, 1 minute over. I hate doing that. Any other questions?
We did have it was more of a comment on that. Those classes are amazing, but segmentation seems like a never-ending job with RBAC.
Oh yeah. Well, security is like it's like working out, not like buying a car. It never ends. It never ends. It is a constant game of, you can call it whack-a-mole or cat and mouse or whatever. And every time resources are added into your world, whether you're talking about utilization of RBAC or other kinds of authorizations, but even just stuff like adding a S3 bucket, every time something gets added, the amount of worries you have go up, right? And I won't say it's exponential because it isn't, but it's greater than linear. Okay, these things are all related to each other, so but they're not related to all of each other. So yeah, I want to respect. You said there was one more?
Nope, that was it. That was just a comment. Yep.
Okay, cool. So Drew, why don't I turn it back over to you to take us out?
Sure. Yeah, and if anybody has any questions after this or wants to reach out and talk to Josh about your specific use case or get on a call with us to kind of dig into that, happy to do that. Want to put out here a little bit about Fugue. So much about cloud security and defending against these kinds of attacks is about knowledge. Knowledge of your environment and denying the discovery of that knowledge to your adversaries that are trying to attack your environment. And that's one thing that Fugue can do really quick for you. So within 15 minutes of getting started with Fugue, you have a complete view of your entire cloud environment across cloud platforms, including every security, vulnerability, and compliance violation in that environment, information about how to address that, remediate it, and be able to bring that environment into compliance quickly in under 8 weeks working with us. So please do reach out to us if you have any questions. Get started with Fugue. It's free to get going. And again, in the time it takes you to get a cup of coffee, you can identify a lot of the vulnerabilities that we've talked about here today and begin to move forward to not only improve your cloud security posture, but empower your teams to just move faster in the cloud more securely and more efficiently. So thank you very much again for joining us. We're glad that you were able to do that. And we will see you next time.